Today we're going to start looking at the area and perimeter of sectors. So we're going to focus in on circles and then at the parts of circles. We're going to do some straightforward questions today to make sure that we have the theory down, but in tomorrow's lesson we'll be doing a bit more problem solving. Before we move on, so the first thing is the sector. So the sector is a part of the area. It is a fraction of the area. It is created when two lines meet at the center of the circle, and they absolutely do have to meet at the center. You can see that we have two radii leading from there, and then what they do is they create that sector, that slice. Here we've got an arc, so an arc is part of the circumference, okay? And then the crucial thing is when we're looking at the measurements involved with the area of a sector or the length of an arc is the angle. So in any of the formulas I'm using today, I'm going to use theta to represent the measure of the angle. So let's revise some of the things that we already know about circles and circumference. So the perimeter is also called the circumference, and we use the letter L for that, so L for length. And as we know that the circumference of a circle is 2 pi r. We've already learned from past work in the junior cert that the area is pi r squared. So we're going to be using those two formulas quite a lot today. Other things we know are a cyclic quadrilateral is a quadrilateral inscribed in a circle. So where the four corners of the quadrilateral lie on the circle, and we know that opposite angles add up to 180 degrees. So we covered that in the geometry chapter. Every triangle inscribed in a semicircle is a right angle triangle. So if you have a right angle triangle and one of the sides is that the diameter, then the angle opposite is right angled. Again, we covered that in the geometry chapter. And the last thing which is important to note is that 2 radians, or 2 pi radians, is what should be written there. 2 pi radians is 360 degrees. So I suppose the challenge today and the next couple of days is that sometimes we'll be using degrees to measure angles, and sometimes we'll be using radians to measure angles. So 2 pi radians is the same as 360 degrees, or if you want, 180 degrees is the same as pi radians. Okay. Okay, so here are a few questions that ask you for the area and circumference of the circles. Now, I'm not going to spend a video going back over this, but I am going to do maybe 2 examples. And what I'd like you to do is pause the video, maybe do 1 or 2 questions more if you feel you need to practice, but actually spend the time doing the questions out, because you will just upskill or practice the skills you already have if you haven't used these formulas in a while. So the first one I'm going to do is number 1. And the radius is 3 centimeters. The area, I always write down my formula, is pi r squared. So that's pi times 3 centimeters squared. So that works out as 9. 3 squared is 9, 9 times pi. And remember, the pi is not getting squared here, it's just the radius centimeter squared. So sometimes you can leave your answer in terms of pi, otherwise they will want you to work that out. So 9 times pi, I'll just use my calculator here, that works out as 28 point, I'm going to round it to 2 decimal places, 27 centimeters squared. The circumference for this one then is 2 pi r, so that's 2 times pi times the radius of 3 centimeters. So again, 6 pi centimeters. If it asked us to leave it in terms of pi, I would leave it like that. Otherwise, I'm going to have to put that into my calculator, and that will give me 18.85 rounded to 2 decimal places. So obviously we know pi is an irrational number. It'll go on forever and ever and ever, so you're probably always going to have to round when it comes to circles, or quite often you will anyway. The second one then is part B. So this time the radius is given to us as 7 centimeters. Sorry, not the radius, it's the diameter. So be really careful. I nearly made a mistake there. It's not the radius, and all of my formulas are in terms of the radius. But the good news is we know that if the diameter is 7, the radius is 3.5 centimeters. So to work out the area, I'm going to go through the formula again. So pi r squared, so that's pi times 3.5 squared. Keep in mind that it's only the radius that's squared, it's not the pi that's squared. So we get 12.25 pi, which works out as 38.48 centimeters squared. And I've just realized I made a mistake when I was doing the circumference previously. It's not squared because circumference is a length, it's just one dimension, so it's just centimeters. So area is squared, length is not. And then finally the circumference here is 2 pi r, so that's 2 times pi times 3.5. So that works out to give us 21.99 centimeters. Okay, so there's just two done out quickly enough for you. Obviously, you don't need to work through all the little steps. I would say always write down the formula, always show you subbed in, and then just show the final answer. Anything in between doesn't really matter, except to you maybe. So the next thing is pause the video, give these a go yourself, and I'm just about to show you the answers. Okay, there you go, and let's move on. So here we want to find the area and perimeter of these shapes made from fractions of circles. So if you have a look at maybe the first two we'll have a look at, you can see that we have half a circle. So for our area, it's just going to be half the formula for the area of the circle. Okay, so that's half of pi. You can see the diameter there is 10, so the whole way across is 10, so the radius is going to be 5. Okay, so you can just pop that into your calculator, and that will work out to be 39.27 centimeters squared. For the perimeter, it's actually a little bit different this time. Okay, so if you think about the perimeter of a shape, it's like how long it would take you to go around the outside. Okay, so we need to work out the measurement of this arc, which is half the circumference, and then we'll need to work out that, which is 10 centimeters. So we're going to have to add up those two parts together. So my perimeter is going to be half of a circumference plus that diameter, which is 2r or 10 centimeters. So the difference between perimeter and area is actually a little bit more straightforward in that you work out the area, you get a fraction of it, done. For the perimeter, you have to break it down into parts. You might need to work out a fraction of the circumference, but then add it on to other sides to complete the perimeter. So that's half of 2 times pi. The radius here is 5 plus your 10 centimeters. Put that into your calculator, and that will leave us with 25.71. Okay, I'm now going to have a look at part B, and I'm going to have a look at basically what fraction do we need. So we can see here that it's a quarter of a full circle, so I'm going to use a quarter of my normal formula. So it's a quarter of pi r squared, so it's a quarter of pi times, and you can see the radius there is 6, so if you were to continue that circle the whole way around, 6 would be your radius. So it's going to be straightforward enough. This pop that into your calculator, and that will get you 28.27 centimeters squared. Okay, again, the perimeter is a little bit different. So I'm going to get a fraction of the circumference, which will give me the arc. So the arc is a fraction of the circumference, and then I just add on any other sides that I need. So my fraction here is 1/4, so I'll change the color of the pen, times the circumference plus 6 plus 6, because you can see that there's two sides there that need to be added in. So it's quarter of 2 pi r plus 12. So it's a quarter of 2 times pi times 6 plus 12. So I'm just going to pop that into my calculator. And that works out to give me 21.42477. So I'll just round it to 21.42. Okay, so there you go. What might be a good idea now is to pause the video, maybe give the other parts a go yourself. Make sure you have it kind of really sure in your own head. There's always more than one way to do these questions. This is just my approach. Today, if I were to go through it again tomorrow, I might have a slightly different approach, but the basic idea is the same. Use fractions to find your arc or your sector, and then add on any additional parts that you may need. So what we were doing in the last question was working out the arc lengths and areas of different sectors. And that was easy to do in those questions because we could see straight away from the naked eye that it was a half of a circle or a quarter of a circle or 3/4 of a circle. We're going to keep that logic as we go through, but the only difference is some of the angles we're looking at won't necessarily tell us the fraction straight away. It won't be as easy to the eye, I suppose. So here we have an arc length. Could we figure out what fraction of the circle is shown? Well, of course we can. So the whole circle, the full rotation is 360 degrees. So if we have got 30 degrees out of 360 degrees, then that would mean that we have a fraction of 1/12. So we have a 1/12 of a circle there. So if I wanted to work out the length of that arc, I would just go 1/12 times the circumference. Okay, so 1/12 times 2 pi r.